Hello, everybody. Thank you again for joining us for the Meet the Scientists webinar. Today is my pleasure to host the BarcelonaBeta Brain Research Center. We have a great team, and to remind everybody that Meet the Scientists is an opportunity to meet the teams of investigators working to end Alzheimer's disease and other dementias. You can learn more about what we're doing in the website that is mat.mgh.harvard.edu, and also learn more through the emails that are sent weekly through the iStart Alzheimer's Association. So to start, so we have enough time for questions at the end. So I'm going to pass it to Dr. Anna Brugulat. But before that, I just want to remind everybody, if you have any questions during the presentations, please use the chat or the QA options. I'm going to be moderating the QA sessions at the end. So Dr. Brugulat, I pass it to you. Thank you again for being here.
Thank you. Are you seeing my slides? Could you check this? Okay, great. Thank you. So first of all, thank you to Joaquin for inviting us to be here in these seminars. And also thank you everyone for coming today to our talk. My name is Anna Brugulat Serrat. I'm a neuropsychologist, and also I'm a postdoc researcher in BarcelonaBeta Brain Research Center. And I would like to start talking about the agenda of today's talk. So firstly, I will talk about the BarcelonaBeta research platform. We will talk about where we are based, which is our cohort, which are our main research groups that we are ongoing in the BBRC, and some of the specific studies in some of these groups. Then we will have Dr. Oriol Grau Rivera. Today is here as a representative of clinical biomarkers and risk factors research group. Then we will have Dr. Marc Suárez, who is the group leader of fluid biomarkers and translational neurology research group. And the last speaker, but not the least, we have the group leader of neuroimaging research group, Dr. Juan Domingo Gispert. Also, as Yakel said, we will have time for questions and answers. So if you want to use the chat for posting any question, please go ahead. So first of all, where we are based. So as the name says, we are in Barcelona, Catalonia, Spain. Actually, we are in the campus of University of Pompeu Fabra, really close to the sea and just in front of the zoo of the Barcelona. So we are in an amazing environment for doing research. Let me put, yes. In this picture, you can see our research building. In this building, we are doing almost all the research procedures that we are doing in our studies. So we have our own MRI machine. We have rooms for doing cognitive and clinical assessment. We have a specific place for undergo lumbar punctions. Also, we have a lab in our building, and in the next weeks, we will have a new lab that I think that Dr. Marc Suárez will talk about this. And also in this building, there are based all the researchers that we work with the data. So what we study, which is our focus of interest. In BBRC, we are focused on prevention. So specifically, we are focused on the early stages of the Alzheimer's disease, which we know as preclinical stage of Alzheimer's disease. And we are aware that exists a different challenge of prevention in this specific stage in terms of new target population, longer phase 3 trials, new recruitment strategies, time to event endpoints, also new cognitive endpoints in terms of composites and continuous measures. And also there are ethical challenges to be solved in terms of the emotional impact or the impact that have the disclosure of the risk in those individuals. So in BBRC, we are working really hard to find solutions in this challenge. We are doing studies based on population recruitment in healthy aging programs, personalized medicine approach, risk disclosure approach, and also primary and secondary prevention. And we are so glad because the last years, specifically the last year, we have increasing a lot with the new research lines, and we think that we are moving forward really fast to improve the understanding of this preclinical stage. So which is our population that we have in BBRC, which are our cohort? So here you have Alpha Registry. You will hear a lot this name, Alpha. alpha comes from Alzheimer and families, and this registry is a data set of 7,500 individuals that once expressed their interest to be involved in some of our research programs. And from this data set, we obtain our main cohort, which is called Alpha Parent Cohort, composed by almost 3,000 individuals. All of those individuals did a baseline visit in which we gathered information about lifestyle factors, clinical history. We did a cognitive assessment, and also we got a blood test sample to obtain the APOE genotype. And which was the result? The result was that we obtained a really very and well-characterized sample of cognitively impaired individuals at higher risk of develop Alzheimer's disease. And you can see here some figures that are present in this paper that you can check if you are more interested in know more about this alpha parent cohort. And which are the characteristics of this cohort? So as you can see here, the main age is 55.8 years old, 63% of them are women, and also they have a really higher level of education. And as a bias, as a recruitment, also we have a higher number of individuals with family history of Alzheimer's disease. And what is really interesting is that, as you can see here in these plots, comparing with the general population, in our cohort, we have a higher percentage of APOE4 carriers compared with the general population. So it was something that was unexpected. And also regarding some risk factors, as you can see here, cardiovascular risk factor is the opposite. Our cohort has a lower level of these cardiovascular risk factors compared with the general population. So we are talking that we have a really clinical healthy population. Then a subgroup of those almost 3,000 individuals did a first MRI. Then from this main parent cohort, we started to create our research platform. One of the studies that we did after the baseline visit was this Alpha GWAS MRI study. The characteristic of this study is that almost all the participants, we have the GWAS of those participants, and we hope that in the near future we will have the GWAS of almost all the individuals from the alpha parent cohort. And this allowed us to start to study the impact of genetics on this preclinical stage of Alzheimer's disease. Then we have our longitudinal study, which is called Alpha Plus, here highlighted in green, which has been included 419 individuals from this main parent cohort. In this study, we gathered again information and more extensive information about clinical history, cognitive performance. Also, all individuals acquired MRI sequences. We get blood test samples in order to obtain blood biomarkers as well. And also, almost all these individuals undergo a lumbar puncture. As you can see, also some of them also acquired amyloid PET imaging, and each of these visits is repeated every 3 years. In the last month, also we have started the Alpha Tau study, which, as the name says, some of those individuals also acquired PET Tau imaging, and also the Alpha Sleep, which is a study that is led by Dr. Yolor Grau, who is the next speaker, and he will talk more about this study. But what is really interesting as well is that even all of those individuals from this Alpha Plus study are cognitively unimpaired individuals, and as we have said, they are clinically healthy. As you can see, that a third of them, they are already in the Alzheimer's continuum. So this for us is really important when start to think about the research questions and when we want to move forward on our research field. Also, in the middle, you can see a COVID-19 study. This study is led by Eider, Arenaza, and it has been included approximately 900 individuals. And the aims of this study is to analyze the impact of the lockdown to the brain health, and also specifically the impact of the lockdown to the female caregivers of patients with Alzheimer's disease. And also here you can say that it's just show that also some of our individuals has been included in the European Consortium studies from IPAT and AMIPAT. And also we have some clinical trials ongoing in which also those individuals are included. So these will be the studies that are focused on the very early stages of this preclinical Alzheimer's disease. But also in the last year, we have started another study which is more focused on this continuum of, in more advanced stages of this continuum of Alzheimer's disease. In that case, we have this study, which is called Cohort study for the identification of blood biomarkers in the population with subjective cognitive decline. In that case, it is included 200 individuals, and this is a collaboration with some of hospitals and primary care centers. And this, the difference with our main cohort is that here, individuals with subjective cognitive decline and some of them memory cognitive impairment are included. And the objective is to validate specifically the blood biomarkers. Which is the result of all this research platform. For us, we are so proud that we have, and here you can see the picture visually that I think that it's better than all. You can see the huge number of variables that we have in BBRC. Since from socio-demographical variables, we have cognitive variables, family history, a huge number of variables regarding clinical history, CSF biomarkers. Also, Dr. Marc Suárez will talk about the long list that we have about CSF biomarkers, but also blood biomarkers. Regarding MRI sequences, we have a lot of measures that has been done by the members of the neuroimaging team. Of course, there are not all of them shown in this slide, but you can imagine that we can assess a lot of different variables. Also, we have the COVID status of some of our individuals. We have lifestyle factors as well, variables regarding PET imaging, and also, as we talk about this study that we did, we have genetic variables, like a part of APOE, also we have telomeres and the GWAS. So which research groups are currently in the BBRC? We are increasing a lot, we are growing up a lot, and in the near future we'll have new groups, but the ones that are ongoing in the in the BBRC are the ones that I'm gonna talk to you next. First one is clinical biomarkers and risk factors research group. This group has a specific research lines, which are reserve, resilience, and lifestyle, association between sleeping disorders, cognitive impairment, and Alzheimer's disease, subjective cognitive decline, epidemiology, and also association of dietary intake omega-3 fatty acids in preclinical Alzheimer's disease. Dr. Grau will talk about some of these research lines as the next speaker, but in this case, I will talk about briefly about this research line, about the subjective cognitive decline. So there is increasing evidence that subjective cognitive decline in cognitively unimpaired individuals may represent the first symptomatic manifestation of Alzheimer's disease. And as you can see here in this figure, it is proposed that this concept, the SCD, occurs at the latest stage of Alzheimer's disease. So this literature, the previous evidence, shows that it's required to understanding this concept and its several aspects to use this as indicator of the earliest symptomatic manifestation of Alzheimer's disease. And in line with these previous assumptions, Dr. Gonzalo Sánchez-Benavides, who is the leader of this research line, started to analyze this specific concept with our cohorts. Firstly, just said that from the 20% of alpha plus individuals, the individuals that are taking part in this longitudinal study present memory or cognitive concepts. And here you can see 4 different main results from different papers that has been published by Dr. Sánchez-Benavides. So the first one in this study was included almost all individuals from the alpha parent cohort. So the sample of this study is almost 3,000 individuals. And here, Dr. Sanchez wanted to explore the association between SCD plus features and cognitive neuroimaging profiles in a population-based cohort. And what was found is that, and as you can see here in this figure regarding memory, that individuals with categorized with subjective cognitive decline obtain lower scores in memory and also in executive function compared to the individuals that are categorized as non-subjective cognitive decline. So these results show that those individuals with subjective cognitive decline plus present a different cognitive profile, which is similar that has been found in Alzheimer's disease. So this suggests and support the usefulness of this concept as an enrichment criteria in population-based cohort. Also, following with this line, in our paper published in 2020, it has been found and show the usefulness of this concept of subjective cognitive decline, also as predicting the presence of amyloid beta status in the future. This is a longitudinal study in which was included 261 individuals from the Alpha Plaza study. And this plot, this figure shows that the self-perception of memory decline increase the probability of having a positive amyloid beta scan. But also not only this is relating this Alzheimer's disease hallmarks, also it is it has been found that in CSF amyloid positive individuals that present subjective cognitive decline also has present more neurodegeneration. So the presence of this subjective decline in these individuals is related to the presence of this marker that has also been associated with Alzheimer's disease. The last study that I'm going to talk to you by Dr. Gonzalo Sanchez is one that you can see here. And this is quite interesting because in that case, the aim of this study was to explore again the cognitive, the clinical, and the structural neuroimaging characteristic of cognitively impaired individuals without self-awareness of cognitive decline. So those individuals, we call them unaware decliners. And that means that the decline reported is by an informant only. So they are not aware of its declining. And this is quite interesting because what has been found in this paper is that these unaware decliners had worse memory performance than controls. And this also was correlated with a hippocampal gray matter volume. So also in this paper, it is shown that not also the usefulness of this subjective cognitive decline as a risk factor for cognitive impairment, but also the information that we know that it is reported from this person. Another line of this research group that I will talk really briefly is this, which is focused on the association of dietary intake omega-3 fatty acids in preclinical Alzheimer's disease. And this research line is led by Dr. Aleix Sala, and this slide pretends to explain for why it's important to analyze this in our cohort. So here you can see in the central part of the slide, you can see the family of the omega-3 fatty acids, and then the one which is in the top is an essential fatty acid. That means that we cannot synthesize it. So this must be obtained by it from diet. So, and the main sources are walnuts, flax, chia, and canola oil as well. So this fatty acid can be converted in our body to an unsaturated fatty acid. And one of the most relevant is the one that you have here in the bottom, which is called the DHA. And this is interesting because this is accumulated in our brain membranes even before birth, and it's critical for brain function. And also it has been found in the previous literature that this DHA, it has been suggested that can improve the Alzheimer's disease features. So taking into consideration this previous literature, Dr. Aleix Sala, it's interesting to explore whether in alpha participants, the intake of these fatty acids is related to some of the variables of interest. And how is doing this research, Dr. Sala? One of the approach is here in the right side of the slide. This approach is based on questionnaires. So we are gathering information about the dietary patterns of our participants in order to check the intake of these fatty acids. However, this approach has some limitations because we are capturing of bioactives other than omega-3s, and also it has a low accuracy compared with other approach. So in order to solve these limitations, Dr. Aleix Sala also is applying another approach, which is in the opposite side of the slide, in the left side of this slide, which is by lipidomics. By lipidomics, we can determine the exact incorporation of omega-3 into membranes. So this method will be solve these limitations. And now Dr. Aleix Sala is working on this specifically with data from Alpha Cohort. Here you can see results of a recent paper published by Dr. Salavilla, in which it has been found that the relevance of this fatty acid DHH. Here you can see a plot in which is plotted the standardized residual cortical thickness of Alzheimer's disease signature, and also the accumulation of this fatty acid. The red lines represent the ApoE4 carriers and the blue lines represent the non-carriers. You can see here that in ApoE4 carriers, homozygotes, it seems that a higher number of accumulation of these fatty acids, it means that they have a better Alzheimer's disease signature conversation of these. So you will have the opportunity to talk with Dr. Aleix Sala in the Q&A and answers, and will be better to answer any questions regarding this study. So the newest research group in BBRC is the Fluid Biomarkers and Translational Neurology Research Group. This is led by Dr. Marc Suárez, who is going to talk today as well. And the main research lines in this group are Neurodegenerative Disease Fluid Biomarkers Lab and the HEVE project Fluid Biomarkers of Aging. And the last group in BBRC is Neuroimaging Research Group, led by Dr. Juan Domingo Gispert. Also, we'll have the opportunity to listen to him today. And this group is focused on cerebral correlates of preclinical Alzheimer's disease and risk factors, expanding the role of amyloid PET imaging, genetic determinants of cerebral phenotypes, novel imaging techniques to detect preclinical Alzheimer's disease, and also generation of an imaging repository in very early Alzheimer's disease. So also you will have the opportunity to know more about some of the studies that are going on in this group. So this is all from my side. So I will give the floor to my colleague, Dr. Oriol Grau.
Thank you, Anna. So I will start by sharing my screen. Sorry. Hope you see the screen now. Okay. Great, thank you. So hello everyone, and thank you very much to the organizers for setting up this meeting. It's very interesting to be able to share with you our research. So my name is Oriol Grau. I'm a neurologist and researcher at BBRC, and I will talk you a little bit about two research lines that are conducted in the clinical biomarkers and risk factors group. So first, I will talk about the line focused on research, resilience, and lifestyle factors, which is conducted by Dr. Arenaza and her team. So unfortunately, Dr. Arenaza could not be here today, and I will explain you about this research line on behalf of her and her team. And so if you have very specific questions on this topic, maybe you can refer directly or reach her directly by email. And next, I will speak about the other research line, which is focused on sleep and its association with cognitive impairment and Alzheimer's disease. So starting with the brain resilience line, Dr. Arenaza and her team are working on brain resilience and its association with different lifestyle, mental health, and brain health factors. And here are some examples provided by them to illustrate their research. So first, they are interested in the early identification of pathological change and resilient vulnerability pathways. And for instance, they have been able to find associations between proximity to parental age at onset of AD and amyloid deposition in the brain. And notably, this association was driven by women. Also, they are working with a panel of biomarkers, including AD biomarkers, glial activation biomarkers, neurodegeneration, or synaptic damage biomarkers, and they have been able to identify different patterns of these or different profiles of these biomarkers, for instance, related to core AD biomarkers or glial markers or synaptic damage and so on, that may be associated with specific pathways related to resilience and vulnerability for cognitive impairment. Second, they are also working on associations between mental health and resilience and resistance, with a special emphasis on women and caregivers. And As an example, during the COVID-19 lockdown here in our country, they collect data on our participants and found that women caregivers and those who are positive for amyloid biomarkers displayed higher levels of anxiety and depression during confinement, during lockdown. Also, they have been working on associations between specific mental health outcomes such as anxiety and proxies of brain resilience and interactions with sex. And finally, they are also investigating lifestyle and socioeconomic variables and their association with resistance and resilience. And for instance, they have recently found that specific socioeconomic or demographic and lifestyle factors and specific neuroimaging patterns are associated with an exceptional performance, cognitive performance in the oldest old. Okay, so now we move to the other research line, which is focused in sleep. So as you may know, sleep is increasingly seen as a potential risk factor for cognitive impairment, but on the other hand, sleep is also, or maybe also, an early AD manifestation. So it has been stated that sleep disruption may increase the risk for cognitive impairment by means of promoting the accumulation of amyloid and tau in the brain and the deposition of these proteins in specific regions that are related to sleep-wake regulation may be responsible of the disruption of the sleep pattern that has been reported even in the preclinical stage of the disease. However, there are some mechanisms that maybe have not been so explored. For instance, the role of inflammation or orexin signaling dysregulation in the association between sleep disturbance and cognitive impairment. And on the other hand, there's a lack of multimodal studies that gather neuroimaging, ID biomarkers, and objective sleep parameters data to answer some of these research questions. So we have previously shown that in cognitively unimpaired participants from the ALPHA study that reported insomnia symptoms, these participants exhibit a worse executive performance and a specific brain structural pattern characterized by change, among other things, that affected regions that are known to be involved in Alzheimer's disease. So with this in mind, and with willing to expand our knowledge on the association between sleep and cognitive disorders, we have launched recently the ALPHA sleep study, already mentioned by Anna in her slides. And this study aims to characterize participants currently enrolled in the ALPHA Plus study, which as a reminder, this study is a longitudinal study where participants are characterized every 3 years with fluid biomarkers, advanced neuroimaging, and cognitive and clinical phenotyping. So we are adding in a subset of these participants objective and subjective measures of sleep, such as actigraphy or polysomnography, and we are also measuring in all of them levels of CSF orexin. So the overall aim of this study is to have a very detailed picture of the sleep pattern in preclinical AD and to investigate potential mechanisms linking sleep with cognitive impairment, such as neuroinflammation or orexin signaling dysregulation. So this is all from my side, and I would like to take the opportunity to share with you that we are soon opening a new position for this ALPHA sleep study, and we are looking for researchers with interest in intersection between sleep and cognitive disorders with experience in EEG quantitative analysis. So if anyone's interested, please contact me at this email address. So that's all from my side. Thank you very much for your attention, and I will leave you with Dr. Marc Suárez.
All right, hello everybody. Let me first try to share the screen. I hope all of you are seeing my screen. So thank you, Riol, thank you, Anna, and thank you the organizers. I think it's a great opportunity to show our center, BarcelonaBeta. And my name is Marc Suárez. I'm also a clinical neurologist, but I am also focused on biomarkers, and I'll try to do research from more the basic and translational point of view, especially now with the biomarkers and very particularly in blood biomarkers now. So let me show, let me see if I can here. Okay, so this is a cartoon that Marta Milan, an excellent PhD student, did for a review that I recommend to you. And these are different fluid biomarkers that are organized with different physiopathological mechanisms: A-beta pathology, tau pathology, neuroinflammation, glial, vascular biomarkers, and so on. And as you can see here, highlighted in green, are those biomarkers that we have measured together and in collaboration with the University of Gothenburg in our alpha cohort. As Anna explained very well at the very beginning, the uniqueness of our cohort is that we very particularly study preclinical Alzheimer's disease. I believe that there are a lot of courses, many courses around the world studying symptomatic Alzheimer's disease, but studying preclinical Alzheimer's disease, it's very challenging and very difficult. We started 10 years ago, and probably most people did not believe us that was important, and now many other courses around the world have understood that studying preclinical Alzheimer's is very important. And from the biomarkers, the fluid biomarkers point of view, we have measured all these biomarkers that are highlighted here in green. So we covered most of the physiopathological mechanisms that are related in Alzheimer's disease, and very particularly in preclinical Alzheimer's disease. And as most of you know very well, one of the big changes these last 2 years in our field has been that we now have finally very good blood biomarkers. It's been a long journey, but now we really have very good blood biomarkers, especially those phospho-tau biomarkers, which can detect Alzheimer's disease very well. Also Amulet biomarkers, neurofilament, and also GFAP, which is an extremely interesting biomarker. And we have also measured all of them together in collaboration with the University of Gothenburg in our cohort. And actually we have shown in our studies that many of these biomarkers that it was known in previous studies that they are very useful, they are increased in symptomatic AD. Most of them, they also increase in very early stages of the continuum in preclinical Alzheimer's disease. And that's extremely important to detect preclinical Alzheimer's disease, and maybe for clinical trials, because that's something that we have to do in our field, to start to doing trials in these very, very early stages. And obviously biomarkers are very important here, especially the blood biomarkers. And let me show some very brief data. Marta Milan published last year this paper in Alzheimer's and dementia, and what we did is to describe the changes of different biomarkers in the continuum of Alzheimer's disease. So here in the horizontal axis, you have the A-beta 42/40 ratio in CSF as a proxy of the temporal evolution of the disease but always in the preclinical stage, because all of them are cognitively unimpaired. And here we have the cutoff that we use for amyloid negative and positives. So a decreased ratio, that means more amyloid deposition, so more advanced in the preclinical Alzheimer's continuum, but always very early in the preclinical. And we see how the tau biomarkers are those that are the first to change, then synaptic biomarkers like neurogranin, then after all these axonal and neuronal biomarkers like neurofilament, and then there are all the other more glial related biomarkers that also tend to increase during continuum Alzheimer's disease, but not as much as the primary pathology biomarkers or the synaptic or neurodegeneration biomarkers. We have also worked with novel phospho-tau biomarkers. As you know, most of the most used CSF biomarker is phospho-tau 181, but there are 217 and 231 that are extremely interesting. All of them work very, very well in symptomatic Alzheimer's disease, but how is their behavior in preclinical Alzheimer's disease? Well, in alpha we can answer this question. And what we see is that especially phosphatide 231 is the one that increases earlier in the continuum of Alzheimer's disease. In this plot here, you can see that CSF phosphatide 231, it's the first one that reaches abnormal levels within the preclinical Alzheimer's disease, and this is followed by 217 and 181, which are also extremely good biomarkers. But if we want to go the earliest as possible, and that's important again for clinical trials, maybe CSF phosphatide 231 is the biomarker to go. So with this, I would like to finish, and I would like really to thank our team, and especially to Marta Milan, who is really, as I said, an excellent PhD student. Most of the data that I showed to you were generated by her. Also, Paul Ortiz, which is our new lab manager and technician, Margot Casals, with his medical student, and very importantly, all the team of Alpha and BRC. And importantly, we are hiring. We just had a ERC starting grant, which is one of the biggest European grants, and would be focused on studying biomarkers, but especially focusing on aging-related biomarkers. And we are looking for basically two profiles, more a biostatistician and bioinformatician profile, and also a postdoc more focused in developing biomarker assays. So if anyone would be interested, please write me here. This is my email, here is my Twitter account, so please feel to write me and we will have a chat. Thank you very much. And now I'll leave the floor to Dr. Juan Gispert, who will talk about the neuroimaging platform at BBRC. Thank you.
Thank you, Marc. I also would like to thank the organizers for allowing us to present our work here today. I will share my screen now. I hope you can all see my screen now. So I will be talking about specifically the research on neuroimaging at BBRC. I will start showing what kind of modalities we acquired in the different projects. So in the alpha GWAS, MRI, alpha plus, and beta ARC studies that Anna has showed you at the beginning of the talk, we acquired a very similar neuroimaging protocol, so that, with the intention of being able to pull images across the different projects. And that includes high-res T1 3D. High-res is 0.75 millimeters isotropic. Then we have an even higher resolution for the hippocampal area of the brain, so to really be able to parcellate and to identify hippocampal subfields. This is an inversion recovery sequence with T1 and T2 contrasts. Then we have T2 and FLAIR, mostly for vascular lesions and other type of space-occupying lesions in the brain. Diffusion imaging for structural connectivity and to study white matter and gray matter microstructure, and resting state protocol for fMRI. And then specifically in Alpha Plus, participants undergo a second MRI visit, including susceptibility-weighted imaging to detect microbleeds, for example. This sequence is also acquired for all the beta ARC participants, ASL to quantify cerebral blood perfusion, and some other MR modalities with more focused interest, like a multi-beat to detect brain inflammation, a sequence to quantify CSF flow in the brain, and magnetic resonance spectroscopy to measure the number of metabolites in different voxels in the brain. Also, we acquired PET imaging. So participants in Alpha Plus have an FDG PET scan at baseline. And we also, all of them have longitudinal amyloid PET imaging. We are starting the follow-up acquisition of that. And also have started tau PET. So 100 participants of Alpha Plus will have a longitudinal tau PET. We have just started that as well. Then we have a system to manage all that neuroimaging information, which is based on XNAT. And you can learn about how we have set this ecosystem up in this paper that was published earlier in the year by Jordi Huguet and Greco Perto. And we also have set up a number of neuroimaging pipelines to obtain these imaging-derived phenotypes, both in MRI and PET, automatically, so that all this data is available as it comes. So as images are being acquiring, we're constantly generating these kind of variables for all of our researchers to have access to them. And of course, there is also thorough quality control procedures for each of them. Then more specifically about our research, with the alpha study and as expected in the recruitment strategy that we followed, we had recruited quite a high number of APOE4 homozygotes. So individuals at the highest risk of developing it in the future, but they were still cognitively healthy. So that we wanted to study this group in particular and to characterize them and their neuroimaging phenotypes. And being APOE4 a gene or the allele that is
They will lose Juan.
Yeah, I think we lost his connection.
Okay, he's back.
He's back now. And
Hi.
we lost you a minute ago, I think.
Hi, Juan.
Hi, can you hear me now?
Yes, yes.
Yes, yes.
I'm afraid that I lost my connection. So we also wanted to characterize APOE4 homozygotes from the neurovascular point of view. And we saw that both APOE4 heterozygotes and homozygotes both higher prevalence of cerebral microbleeds, for example, as compared to APOE4 non-carriers. But it was only the homozygotes that had at least one microbleed that they had a higher number of microbleeds in the brain. So as a conclusion, we could say that homozygotes have this brain of homozygotes is more vulnerable to cerebrovascular insults. Another type of risk factors we're interested in is pollution and urban pollutants. And we have a number of studies showing associations between pollutants with cognition and also with some neuroimaging phenotypes, including the AD signature for cortical thickness, showing that green spaces correlate positively with the cortical thickness in areas known to be atrophied in Alzheimer's disease. And also, for example, showing that healthy individuals with higher exposure to NO2 have higher levels of amyloid deposition in the brain. Another line of research is on amyloid PET and to expand the use of amyloid PET. So at the beginning, we were interested into setting very sensitive cutoffs for amyloid positivity using the centiloid metric that tries to harmonize quantitative metrics of amyloid in the brain across tracers and pipelines. And to do that, we took advantage that we had CSF also in the same cohort and merged it with ADNI so that we could identify the earliest detectable alterations in amyloid PET with centiloids. And we came up with a cutoff value of 12 centiloids, which might be regarded quite low, but this has been later validated with independent cohorts and independent methodology. And even more, in a follow-up study in one of the European projects that we participate on, which is called AMIPAT, we merged alpha PET scans with data from Amsterdam cohort, and we could say that even with these very early cutoff values, these alterations could be detected visually by expert raters. And we could also develop a visual staging method to identify amyloid abnormalities in different brain regions through amyloid PET. And finally, we also looked at the associations between amyloid deposition in the brain with all these biomarkers that Marc has presented in the previous talk, biomarkers of tau pathology, neuroinflammation, neurodegeneration, etc. And we could see, for example, that amyloid in the brain was associated to a number of, with p-tau, with neurofilament light, also with inflammatory markers. But for example, all the associations with inflammatory markers were accounted by the association in mediation models, which showed that all these associations were mediated through p-tau and or NFL, so a marker of neuroinflammation. But interestingly, we show that the association between cerebral amyloid in the brain and neurofilament light, so a marker of neurodegeneration, was not fully accounted by p-tau, suggesting that there may be a direct link between early amyloid deposition in the brain and very early neurodegeneration. And finally, just to end up my presentation, we also say that we have a GWAS characterization of the alpha study participants, so over 2,700 of these participants. And there's plenty, again, of phenotypes to correlate this genetic information, like clinical history and cognition, all these MRI and neuroimaging biomarkers and phenotypes that you've just seen, these environmental and lifestyle factors, and even telomere length information. And as means of characterizing the alpha cohort from a genetic point of view, I will show you that we've calculated a number of polygenic risk scores. That was a work that Natalia Vilor presented in AAIC in the previous year, in the previous conference. And of course, as expected, we have increased polygenic risk scores for Alzheimer's disease and amyloid beta and tau. But also in the alpha cohort, we have an higher polygenic risk score variability in other AD risk factors like diabetes, hypertension, or other neurodegenerative diseases like Parkinson's disease or even stroke. So again, plenty of data, plenty of data to study and to support hypotheses, to study and to really try to understand better these preclinical stages of Alzheimer's disease. And just as well as the other presenters today, we also have positions available in the neuroimaging group. So if you're interested into working in trying to understand better preclinical AD through neuroimaging and want to work in Barcelona, so please feel free to contact us. And thank you very much again for your attention. And I guess we are now open for your questions. Thanks.
Thank you, Rari, for great presentations. Yeah, I'm gonna give the chance to the ones that are attending to ask any questions. Please feel free to use the QA option if you have any pending questions or comments. And when you're writing your questions there, I can start with a couple of questions that I have. And let's see if I can put it here together. So the first of all, like, I think I was very impressed by all the research that you are doing. I actually learned a lot from the Barcelona group, as I call it, and I'm very impressed. And there is a lot of research going on. So and also trying to get like putting all the pieces together, everything that you're doing over there. The first question that I have is actually for Dr. Brugulat. That was the first one. I started like writing down all the questions in order. So you were talking about the subjective cognitive decline and some of the studies that it has been doing there, and also how it's correlated with some biomarkers. But you have now at this point like a lot of data, longitudinal data in these individuals, and I was kind of like wondering if there is if you have a sense, or if your group have a sense of how many of the individuals that actually have subjective cognitive decline at baseline actually progress to MCI or even to dementia in the past 10 years, just to get a sense of how Yeah, like the percent of individuals that actually convert or progress to a clinical condition, of those that were actually linked to biomarker from those studies.
Yes, thank you. I think that we have the opportunity here where we have Dr. Gonzalo Sánchez-Benavides, who is leading this research. I think, Gonzalo, you will be the best for answer this because he's the one that he really knows how this concept is in our cohort.
Yes, thank you, Anna. Yes, as you may know, the SCT is known to increase the risk of cognitive decline or between twofold and threefold at 3 years. But in our cohort, we are collecting the first longitudinal follow-up for the individuals, and we still don't have the whole data set to answer this question. We have the feeling that there are some degree of decline. This is a clinical feeling from the people that are collecting the cognitive data, but we are still collecting the data. And I think that our data will match this previous knowledge regarding the progression in SCD individuals.
Great. No, I think that would be super, super cool. And you have this very unique opportunity to actually get closer to that answer. So yeah, it'd be great to know. Okay, so you have a few questions. So Anna, you wanna take a look?
Yes, so we have one question regarding what is it like to live and work in Barcelona? So this is, well, actually you have here all the people that we are already here are people from Catalonia, Spain. So for us, I think, in my opinion, is great. So as I said that previously, regarding the environment where we are based, it's amazing. So this is an extraordinary opportunity to know the city and specifically to just do walk to the sea if you are just overwhelmed or something when you are doing research. So and also I think that it's in terms of researcher, I think that it's really nice to know that we are trying to make collaborations. We are really open the different research centers in Barcelona to make collaboration between us. And it's something that we in BarcelonaBeta, we are really aware that it's important to make contact with other ones. And yes, so this is my opinion regarding this question. I don't know if you have any more thoughts.
Yes, no, I would like to say that even though all of us are locals, the working language in BBRC is English. So our meetings are held in English. And we have also investigators from other countries and from abroad, and it's a rather normal and natural thing for us. Also, Barcelona is a relatively small city in the sense that you can even walk or bike to work if you live in the city. So from that point of view, it's I would say it's quiet, and of course it's you have the sea. And it's I would say a very pleasant city. So if you can match your personal life in a nice city and do interesting research also with good collaborations, I think that's a very good balance.
Yes, and if I may, I would like to stress this international atmosphere that we have in BarcelonaBeta. We have PhD students, postdocs from all around the world. The language of work is English, and we want to keep it like this. So that's very important for us that we really have a very international atmosphere.
Thank you. And the second question, is asking about from Johnny Mejia. He's asking, given the huge amount of data that you have, are you planning to apply machine learning methods to analyze the data?
Well, I can answer to that. We have already been applying some machine learning and artificial intelligence methods to ask some questions to the data. But even though, we have a lot of variables, but we don't have that many number of individuals in the end, because even if we look at the biggest cohorts, it's around 1,000, 2,000 participants, and that might be relatively small numbers for, unleashing all the potential of some of the really powerful machine learning methods. So normally what we try to do is we try to pool our data with some other sources of data, external collaborators. First, to increase the number of cases, but also to verify the generalizability of our findings, because in the end, if we tune our algorithms only with our local cohorts, there can be plenty of bias, and then all our predictions might not be generalizable to other cohorts or to the general population. But this is a really interesting and emerging topic, and we certainly have interest in pursuing this kind of research in the near future. So if any of you are interested into applying this kind of methods with our data, well, we will be very happy to hear your ideas and to try to set up collaborations.
Thank you. And I don't see more questions. Feel free to type your questions. I'm gonna move with my own questions since we have a few more minutes. The questions that I have next is for Dr. Sala Vila. Like Anna was showing some of the work with the DHA and the diet, and she showed some like a graph with the cortical thickness. But I was kind of wondering if you can tell us a little bit more about that study, but also if you had looked at other biomarkers or even like markers of inflammation that we know that is also kind of like usually linked to parents or diet and stuff. So I wanted to hear your thoughts about that.
Yeah, thanks for your question. Yes, in that paper, Anna stressed out what was the most important, the most thrilling finding that we had. However, we also checked for association with microbleeds, and we also checked association with cognition and also with white matter hyperintensities. We found no association for white matter hyperintensities, and regarding microbleedings, we found association for DHA, but not restricted to APOE4 homozygotes. So maybe the most important finding that it was that intake of DHA was associated with a preserved cortical thickness in the AD signature, but only in APOE4 homozygotes. We are planning to keep following this this path. We are starting to search for associations with biomarkers, so cerebrospinal fluid biomarkers and PET amyloid as well. We are also trying to search for associations with markers of glucose hypometabolism and AD signature or brain aging signature as well. So we are trying to keep following this path. But instead of working with data obtained by food frequency questionnaires that is not as exact as we can obtain with lipidomics, we are trying to focus on objective data, so lipidomics-based data.
Perfect, no, thank you. And with that, I think that we had to finish the presentation now. So thank you again, everybody, for joining us today. I just want to be mindful of the time. So I'm going to be sharing the link or the recording with everybody. So you will get the link a few minutes, probably like later today. But thank you again, Anna and everybody for joining us, and Anna for putting together the team. I know that it's taking a lot of coordination too. So I really appreciate everybody joining us and making really giving excellent presentations today. Thank you. With that, have a good day, good evening for you guys as well. Thank you.
Thank
you
so
very much.